Okay, so we have found our normal stress. So going back to the element, right, we have distinguished our normal stress. Okay, so the next thing we're going to look at is we're going to go into look into our shear. So our shearing stress due to the torque. Okay, we have now to deal with the right. So due to the torque Tx, so we're going to find shear Zx is going to shear Xz. So the torque is Tx over J multiplied by C, right? So this is we found that the torque in X is 27600 multiplied by C divided by pi over 2C to power 4. That's the formula for polar moment of area. So this will be 27600 times 2 be 55200 over pi C cube. Okay, so now we have everything. So now we want to find, okay, we want to find our stress max and stress mean. Okay, that's what we want to find. So we know why, because we are going to use this criteria over here. Okay, we're going to apply this criteria over here, where shear stress max is equal to half of stress max minus stress mean. Okay, so because we're going to apply okay. So like before, we are going to find our center of the circle. Right, so we're going to find center of circle. Which correspond to our stress average. Right, so stress average will be equal to stress X plus by stress Z divided by 2. Right, and we know that stress Z based on our element, right, that we draw before, we know that stress Z is equal to 0. So this is equal to minus 25 okay over pi C squared minus by 72,000 over pi C cube, then multiply by half. So I'm going to make a common denominator so it's easier for us to write. So this will be equal to minus 2,500 C minus by 7,200 divided by 2 pi C cube. Okay, so the next thing we're going to do is we're going to find the radius of circle. Right, and the radius of our circle happens to be our tau max. Okay, happens to be our tau max. So let me bring the sketch of our mole circle over here. So this is what we have sketched. Okay, I'm going to change the I'm going to start on the next page anyway. Okay, so we're going to realize that that's the end of the page. So we want to find the radius of the circle now. Right, which correspond to our tau max. Right, so if we were to draw a line over here, right? So we are going to find the radius. So this is the radius that we want to find. Right. Right. So we know that the distance from here to here, this is also our stress average, right? So this from here to here is our stress average, and this happens to be the same from here to here is our stress average, and this height over here is our shear xz. Okay, so from here we can find our tau max. So tau max will be equal to square root. So we just found our stress average. Okay, so we just found our stress average over here. Copy. I'm going to paste here. Right, so this is our stress average. Okay, and then this whole thing is squared plus by our shear value, which is equal to, let me go back to the previous page. So our shear is here. Okay. Then this whole thing is squared. Okay. So now we found our rate. So we're going to find our stress max. And we're going to find our we're going to find our stress max. And we also want to find our stress mean. Right. So this will be equal to tau max. Oh, hold on. Yeah, so stress mean. So will be equal to our stress average, which is equal to minus 2500 C minus by 72,123 divided by 2 pi C cube, right? And then will be plus minus by square root, right? Square root of minus 2500 C minus by 72,000. Okay, this whole thing squared divided by 2 pi C cube, and then plus by 55200 over pi C cube. Right? So when we do the formula that we're going to apply now based on Tresca criteria is I've written down here is this one. Okay, so I'm going to copy and paste this formula over here. So this is the formula that we're going to apply. So when we do stress max minus by stress mean, right? So it's basically this value right? I paste. I don't want to write again, right? So our stress max, so will be a plus down here, right? Then I put a bracket. Then minus, right? Minus by our stress mean. So it's still the same thing. Take the whole thing, excluding the equal sign, okay? So that is our stress. I leave it another space. Okay. Minus, and then down here, because it's minimum, it's minus down here. So you realize when stress max minus stress mean, you cancel these two values, right? And then this one, you take out the brackets plus. So stress max minus stress mean in the end of the day, at the end of the day, will be equal to 2, right? So this will plus, so this will be equal to 2, right, of this value. Right. So based on the, so we found what is stress max minus stress mean already. Okay. So we know that we have to apply tau max is equal to half, right? Stress max minus stress mean. So we know what's our stress max minus stress mean. So at the end of the day, this will be equal to square root of minus 2500C minus by 72,000, right, over 2 pi C cube, right, squared plus by 55200 divided by pi C cube. Okay, so this thing again squared, right? And then we know this entire equation, right? This entire equation must be equal, right? Must be equal to tau max, which is equal to 50 times 10 to the power 3. Okay, so we're going to solve this equation. Okay, we're going to, so everything is online. So what we're going to do is we are going to use Excel to solve it. Okay, so we are going to rearrange this equation, right? So it's equal to square root. So is this entire equation, right? Minus by 50 times 10 to the power 3 is equal to 0. Okay, so I'm going to, I don't know whether have you all used GoSeek, but that's what I'm going to use. Okay, so I'm going to use Excel now. I'm going to teach you a very simple program with Excel. Okay, we're going to do a very simple program with Excel. So I'm going to trigger Excel now. Okay, so I'm going to magnify this really big. Okay, so we are going to go into data. Okay, so click data, and the one we're going to use is under forecast, and we're going to go for what if, and the thing we're going to use is GoSeek, as you can see down here. Okay, that's what we're going to do. So GoSeek is seek the constant. Okay, so down here we are going to have our C value, right? So the C value, I'm just going to put 0.1. Okay, so that is our C value equivalent to our C value that is over here. It's exactly the same thing. That is our C value. Okay, then the first term, okay, is equal to minus 2500, okay, multiply by C minus by 72,123, right? And then after that, I'm going to close bracket, and then divide by 2 times by pi times by C power of 3. Okay, then the whole thing power of 2 squared. So I'm going to use a number like 2. Okay, I'm going to use 2 number. I'm checking my calculation now. Okay, while doing programming Excel, you have to make sure that you have to know the absolute value with your calculator. If not, you don't know whether it's right or wrong. So I'm going to do this first. So 2500 times 2 minus by 72123 divided by 2 divided by shift pi divided by 2 power 3 squared is equal to 17768. I get difference. So hold on, 2500 times 2 plus by 72123 divided